Okay. I do feel like well, I am talking to myself, but it's so weird without having all you guys here to do this with. It's weird. All right, so let's do some definitions. Our sample space is the set of all possible outcomes. Okay, so if I have a sample space of rolling a six-sided die, that means my sample space is going to be all the six sides. So 1, 2, 3, 4, 5, and 6. Okay. All right. Revisiting our definition of probability, that is the likelihood an event will occur what's the probability that something's going to happen, okay? And it can be written as a fraction, decimal, or percent. However, it is usually as a percent or a fraction. It can be a decimal. You don't see that very often. All right, and the symbol would be the probability of A. A is your actual events. And our formula for it was the number of favorable outcomes over the number of total outcomes. Alrighty, so let's find the probability of a couple examples here. So rolling a 2 on a six-sided number cube. Okay, so these two here, I'm actually using a number cube. So for 1 and 2, my sample space is going to be 1, 2, 3, 4, 5, and 6. Okay. And so I have 1, 2, 3, 4, 5, 6 total outcomes. And rolling a 2, there's only one chance of that. So my probability would be 1/6 or 16.7%. Okay, now if I'm rolling an even number, I have 1, 2, 3 opportunities for that. And so my probability is 3/6 or 1/2, 50%. Make sure you always simplify. Always, 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 always. Okay, for number 3, we're flipping a fair coin. So a fair coin is basically a coin that has not been weighted down. Like if you remember the Ocean 11 movies where they weighted the die so it would always turn to a certain number. That's the same thing with the coin where it's weighted a certain way so that it always lands on heads or it always lands on tails. Okay, if it's a fair coin, then it's not weighted. Okay, so I'm flipping a fair coin and landing on heads. So my sample space is going to be either heads or tails. And I want the probability of landing on heads, so I would have 1 out of 2, or 50% probability. All right, so the next one, I'm selecting a green marble from a bag. It's got 3 red marbles, it's got 4 green marbles, and 5 blue marbles. So my sample space is going to be 3 red, 4 green, and 5 blue, which gives me 3 plus 4 plus 5 total marbles in the bag. So I have 12 total outcomes, and I want to know green, at which I have 4, so that gives me 4/12 which is 1/3 or 33.3%. Okay, so that's just some of your simple basic probability. Okay? All right, so now let's use a Venn diagram to show all of our different outcomes. Okay? So Lila's spinning a spinner. It's got sections numbered 1 through 8 and recording the results. So event A is going to be my odds, and my event B is a number greater than 2. All right, so let's go through each of my numbers. So I have number 1. It is an odd, but it is not greater than 2, so it's an A. Number 2 is not an odds, but it's also not greater than 2, so it's outside my big set. Now I have 3, it's odd and it's greater than 2, so it's going in the 2. Then I have 4, not an odd, but greater than 2. 5 is odd and greater than 2. 6 is not odd, but greater than 2. 7, and then 8. Okay? So that basically shows all of the different odds that I have. So what's helpful about the Venn diagram is, if we go to the next page, it will help us to figure out what our probabilities are, okay? So let's show a Venn diagram again. I have A and I have B, okay? So the probability of A, can you see both? Okay, probability of A was I have 8 in my whole sample and I have 1 here, so that's 1/8. The probability of it being a B is I have 3. Wait a minute, I just did that wrong. Yep, I forgot something. What did I forget? I forgot my 3 in the middle. I have 3 in the middle, which that's 3/8, and those are also 8s. So I have 1/8 plus 3/8, which gives me 4/8 or 1/2. So the probability of B, I would have 1, 2, 3/8 as well. So 3/8 plus 3/8 is going to give me 6/8 or 3/4. The probability of A intersection B. Intersection means, Nick, what's intersection mean?
It means everything that crosses in between each intersection.
The ones that's included in both, and since I already have that one here, that gives me my 3/8. And then the union of A and B means everything between all three. So I have 1/8 plus 3/8 plus 3/8. So I have 7/8. And the complement of everything but A and B. Well, what am I missing? If I have 7/8, I'm missing my 2. That would be the 1/8 as well. Alrighty, so we can also use tree diagrams to be able to figure out our probability. So Miguel is doing an outfit, 2 shirts, 2 shorts, and 3 socks. So let's draw a tree diagram. So I have a tan shirt and a red shirt. And then I can either have gray shorts or khakis. Gray shorts or khakis. So on those 2 I have 4. Now 3 socks. I have black, navy, and white. Black, navy, white. Black, navy, white. Black, navy, white. Okay, so that means in my sample space I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. Okay, and let's double check that using our counting principle, which would have said I had 2 times 2 times 3, which gives me 12. So I did that right. Awesome. Okay, so if each outfit has equal probability of being chosen, what's the probability I'm going to get a red t-shirt, khaki shorts, and white socks? Well, I have red, khaki, white. That's just one option out of the 12 different. Okay? But now if I want a tan shirt and gray shorts, so I have tan, I'm not even going to look at the bottom. I have gray shorts. How many choices do I have after that? 1, 2, 3. So that gives me 3 12s, which is 1/4. And then the probability that I'm going to pick just gray shorts, that's the only qualification for it. Well, my gray shorts, I have 1, 2, 3. This gray shorts, I have 1, 2, 3. So that gives me 6 12s or 1/2. All right, last ones, tables. Tables actually make stuff super easy. All right, so the first thing we need to do is total up our totals. So 15 and 35 gives me 50. 26 and 24 is 50. That's 50. 32 and 18 is 50. And my rock was 98, and this was 102, which then both equal 200. Perfect. Okay, so what's the chance the student chosen at random is a 9th grade student? All right, so all I need to do is look at, who prefers rock? 9th grade and rock. I have 15 of those, okay? And this is a chance that any student's chosen, so I'm going to use my total column, which gives me a 7.5%. Okay? All right, the next one, I have a 10th grade in rap. So I'm at 10th grade in rap. That gives me a 24. Again, it's any student chosen at random, so again, I'm going to use the 200. That gives me 12%. And then now I have a randomly select student preferring rock. So that means out of all of them, that gives me a total of 98 out of 200. And so that's 49%. All right, now let's look at an 11th grade in rap. Okay, for 11th grade in rap, I have 25. Okay, now this is the different section, is that I'm choosing out of the 11th graders. So that means my total is only 50, which will give me a 50%. And so again, now if we look at just the 12th graders who prefer rock, that's going to be 32, but I'm only looking at 12th graders, so again I use the 12th graders, and that gives me a 64%. All right, 2 pages of practice. The next page, basically sample spaces, tree diagram with probability, and then a chart with probability. Do that for your homework. And then when you're done with all of that, you can work on your coloring. And I will see you tomorrow.